AIOps Evolution Weekly.
Welcome, everybody, to the AIOps Evolution Podcast. My name is Sean McDermott. I'm your host. Today, I have with me Phil T., the CEO and founder of Moogsoft. So as everyone knows, we've kind of been talking about, Season 2 is really about us focusing in on the products and the vendors in the market today and understanding what they have to offer. So we are, I'm honored to welcome Phil. You know, Phil, you and I have known each other for 20 years, and welcome back to the podcast. You were on last season, just kind of talking about AIOps in general. So welcome back.
Yeah, it's a pleasure to be here, Sean, and always keen to support further education about such an important subject. Yeah.
Well, you've pretty much dedicated your life to it, and we've known each other for a very, very long time, back to the Micromuse and Riversoft days. So I'm keen to kind of understand and get you to talk about that history with regards to what you guys are doing today. But before we get started, why don't you just kind of give a quick bio about yourself so everybody kind of understands what you've done and what led you here?
Yeah, so I guess kind of going back to where we first met at Micromuse, probably what I'm best known for all of those years ago is writing at least the first couple of versions of Netcall, and then leading that team as we co-founded Micromuse and brought Netcall to market. And I kind of got into that. Everybody's got an accidental story of falling into the software industry, and my accidental story was as a struggling academic, a theoretical physicist, I needed to earn money and found my way into a company called Avant-Garde. That's sort of where I learned really the bones of the operations discipline in software, and saw an opportunity for Micromuse. But the key theme that has followed me all the way through is this need to be able to understand the data that people monitor in an operational context and kind of give them a timely indication of actions that they can take to avoid customer impact. Stop the network going dark, stop the application failing to be available. And this has been a problem that has haunted the commercial use of technology since that fateful time when the CEO of American Airlines sat next to Tom Watson Sr. On a flight and bought the first mainframes 50, 60 years ago. So this is it's a key discipline. It's evolved a lot, and through Micromuse and Riversoft and now onto Moogsoft. Essentially, what we've been doing is throwing ever more complex and ever more capable technical solutions to ever more complex and ever more difficult to understand infrastructures that have evolved as businesses have sought to deliver services more and more increasingly digitally intermediated, and with better and better capability, functionality, and quality of service for their customers. And at Moogsoft, we've been sort of very proud to to pioneer the use of AI techniques as the the latest phase in that evolution. So there you go, nearly 3 decades of trying to fix the same problem, which brings me in mind of somebody called Max Planck, who is famous as a physicist, who, after he was lauded and given a Nobel Prize, said, well, he failed at so many things, he had to get something right eventually. So it feels like a lifelong's work, and I don't think it's ended anytime soon.
Well, you certainly have dedicated your life to operations and making operations better. And I've spent the last 25 years, and man, we go way back to the very, very beginnings of this. And when you first put your first guy at Micromuse on U.S. shores, and I actually think he works for you now, right?
That's right, yeah. Well, he doesn't like the title. I kind of refer to him as FBOG, first boots on the ground. But he absolutely was. Yeah, down in Richardson, Texas, working with a guy called Ken Barth, when Micromuse was 2 people in the US. He was the first technical dude.
Yeah, exactly. And so it's been quite a ride. And you're right. It's just, we continue to kind of fix the same problem, but the problem just gets more and more complex, every year. And therefore, you got to apply new technologies to it. And that's what's exciting to us about AIOps and where we're going with it. So let's spend a little bit of time. We do that with everybody. Let's spend about 10 or 15 minutes talking about your perspective on AIOps, where we are today, and where you think we're going in the next say 3 to 5 years or whatever timeline you feel is relevant?
Sure. So let's go back to the beginning of why there is, in my view, a thing called AIOps. And I suspect that the starting point is sort of the mass deployment of virtualization technology in the enterprise. So, VMware and virtual machines, I guess 2008 or thereabouts onwards, people started really deploying it at scale. And what we became aware of, myself and Mike Silver, my co-founder, was it was around about that same time that we started kind of getting reached out to by old customers of ours from the Riversoft and the Micromuse days, and they were saying pretty much the same thing, which is we can't use the correlation in netcall anymore. And when you dug into what they really meant by that, what they were saying was the correlation in netcall, like most legacy products, most products, frankly, still today, uses a rule base. So literally a long list of if-then-else statements. If A matches B, then do this. That tries to hunt.
I remember writing a lot of those rules back in the day.
It's scary. I mean, we were looking at one the other day, which was a trap processing module from an existing netcall implementation. Tens of thousands of lines of if-then-else statements. But it's not just the old products. I mean, there are modern products that use regexes and think they're doing something, magic, and it's really just a matching rule in that regard. But it's so they've got all of these statements, and what they're trying to do fundamentally is say these are the ways in which my fixed infrastructure can break, and these are the alerts that produces. Now go hunt for those alerts, and if I see them, conclude this is how my fixed infrastructure broke. And of course, the logical fallacy in that is that the infrastructure is fixed. As soon as you have virtualization and other kind of infrastructure as code, I guess is the more modern term for it, type stuff in your environment, the rules-based system fails. So, Mike and I scratched our head a fair bit about this, and we were kind of, surely, IBM will sort this out, right? I mean, it's, they've got, thousands of researchers on staff, and, they own netcall now, so they'll fix it. But, this reach out kept on.
And they were famous for Watson, right? Which was
yes, yes, Watson indeed. It's very good at playing chess. But there you go. Which, by the way, is another rules-based system, which is a very large one. So if anybody's seen the Queen's Gambit, will attest. Quite talented. But in any case, the reach out kept going on. We were scratching our heads thinking, what can be done about it? And coincidentally, what Mike and I were up to at that time was we both decided to start an incubator in the UK dedicated to try and work out how you can take sort of next-gen innovations that were current in academia at the time and turn them into companies. And what most people were talking about was a rebirth of statistical machine learning, in essence. So natural language processing was the buzzword that was flying around a lot. And the idea was if you have a lot of data, what techniques can you use to kind of infer and deduce meaning from the data? And it all kind of came to a head at a lunch. Mike and I went with some senior people at Deutsche Bank, I think it was at the time, and we had a few glasses of wine, and an argument broke out where Mike basically challenged me. He sort of said, well, Phil, you talk a lot about all these capabilities with machine learning. I bet you can't use it to fix the root cause analysis problem for virtual infrastructure. And I kind of don't like being goaded in that way. It's almost a bit like sort of Back to the Future. Don't call me chicken. It's like, don't tell me I can't do it. So I sat down and started trying to work it out, and we came up with an idea for the company that became Moogsoft, and we started down the path. And I'll never forget, very, very, very early on, Sean, because we acquired Union Bank of Switzerland as a design partner. Really, they weren't really a customer at the time, but they were certainly paying us money, which was nice. We were out in Zurich talking to an executive there that ran a whole bunch of their IT operations inside of the bank. And I remember him saying to me, so you want to use artificial intelligence to run my network? And I'm like, yeah, sure. It's the only thing that can solve the problem that you've got with all this virtualization. He said, yes, but if it gets the wrong answer, who do I fire? I can't fire a software program. But if my operators get it wrong, I can fire them. And it was kind of, we did run into a lot of that kind of, what you mean you're using robots to run the system? You must be mad.
So where do you see it going? Like, so you and I have had a lot of conversations, and I can refer everyone back to season 1 podcast and the conversation we had there. I think it's one of the first episodes we released. And we talked about, AIOps and kind of, where do you see it going now? Like so 9 months later, right? This technology moves fast, right? Everything's kind of moving fast. So we're 9 months from the last podcast. So where do you see, what have you learned in the last 9 months, and where do you see things going in the next, say, 3 to 5 years, or whatever timeline you find is relevant?
So, I would say that, the first thing is to focus on the customer. And, what has been going on in the last 9 months with the customer is, whether it's the large enterprise or otherwhere, people have been getting used to this much more sort of remote way of working and, distributed form of operations. And it's kind of forcing centralized IT to think and behave a little bit more like distributed SRE and DevOps, and accelerating changes that I think, with all of us, you included, Sean, we've been calling, out as the future for a number of years. This kind of much more application owning of operations and responsibility for availability. So this is kind of, it's doubled down and widened on a use case basis the types of telemetry that we need to start including in our analysis. So we started Moogsoft very focused on events and logs, alerts, the kind of the point in time notifications of status. And where we are today is we've significantly added the traditional observability telemetry into that. So metrics and related traces, logs to a lesser extent today, but that will come simply because you need to be able to give much more depth in the diagnosis of an outage or a failure of a given application. And so, that has been key. And what that does is it sort of put pressure on the evolution of the algorithms that you use to do this kind of deeper analysis. Because you need to be able to both do it at scale and also do it with, a significantly broadened set of data that you're doing it on. So there's a continual sort of poacher gamekeeper thing going on here where, the problem continues to get more complicated. That seems to be a law of the universe. And, what we have to do as a software vendor is continue to upgrade our capabilities. I mean, we filed somewhere in the region of 54 patents at Moogsoft, and 35 of them, I think, now are granted. And we continue to file at the rate of 1 or 2 a quarter, which reflects the fact that we at Moogsoft have a team that is dedicated to looking at the data that we get and evolving additional algorithmics that we put into the product. So, we've added in the last year significant new capability around anomaly detection with metrics. There's more to come on that front, quite significantly more to come. We've been doing work on, automated correlation definition, sort of discovery, which is applying some aspects of genetic algorithms to the job of auto-configuring the tool. We've been extending other use of importance metrics. I mean, we pioneered the use of information theory to spot significant events many, many years ago. And now we're looking at different ways of using dependency graphs to improve upon that, including pioneering something which is so novel. Even in academic circles, it's poorly understood, which is, the shape and topology of graphs that we're starting to see has practical utility. So I would say that the the significant change is the shift to remote has driven people into more of an SRE DevOps kind of mindset, even if they're not all the way into that way of working. And for us, it's broadened the types of data that we consider as kind of fair game for AIOps.
Yeah, I think this idea of DevOps and SRE is probably, there's you and I have been in this game for a long time, and there's been a couple major shifts right over the years, and I think this, as infrastructure has become more and more fault tolerant, just built into the OS, it's become more reliant on the fact that really the focus should be on the application, right, and the service that's being delivered and the experience of what your end users are looking for. So, and that becomes much more complicated with the vast amount, the complexity of application development and application architecture now, and the massive amount of instrumentation. So, to me, AIOps is a natural offshoot of what's been coming for a while, and that is a shift towards the application itself and the experience and instrumenting that. And by doing that, you're creating massive amounts of data that then has to be processed that we as humans can't process, right? So all right. So this is good stuff. So let's move into Moogsoft. Let's talk about Moogsoft and what you guys are doing. I'm very keen on a couple things to kind of bring up to you. I'll let you talk about what you want, but indulge me and hit on a couple things, because I've known, like I said, we've known each other a long time. I've known your work. We were a big, all disclosure, we were a big Micromuse partner back in the day, and one of the things that we focused on a lot was scale. Right. And Micromuse at the time was really the only platform that could scale for our customers, which were large financial institutions and telecommunication companies. And I mean, that technology is still out there. Right. And, so talk, when you talk a little bit about what you guys are doing and kind of highlight to the audience what Moogsoft is really all about. Hit on that a little bit on scale, because that to me is kind of near and dear to my heart.
Yeah, and again, back to the old days of netcall, that was a primary consideration. I mean, when you're dealing with, I remember the big first push of the internet. When you had guys like Unet going around doubling the size of their network every 72 days. If you can only process 4 or 5 events a second. You kind of hold below the waterline in terms of being able to cope with stuff at scale. And, certainly as you start to extend into other forms of telemetry like metrics, time series data, the scale requirements become increasingly high. But here's something which I've observed. Legacy is a term that consumes all. I mean, it's undoubtedly the case that netcall is a legacy product. We would look at it and say it's old. It's designed for a world that, doesn't necessarily exist anymore. You pointed to the infrastructure is so reliable, people care about applications, which is absolutely a thing. Who cares about SNMP these days? As an example, it is much more sort of application focused. But, there are seemingly modern providers of software in this market that are frankly legacy, designed their SaaS platforms, 8 or 9 years ago, that are bounded to, a handful of events per second, that claim to do AI when really all they're doing is, smart filtering and, rules-based matching of alerts. And, the truth of the matter is that a modern infrastructure demands a vendor that continuously reinvents itself, which is why Moogsoft has gone through, major platform reimaginings, including an entirely net new SaaS infrastructure that is, is SaaS version 2, if you like, capable of dealing with tens of thousands of ingested data points a second. We have customers up in the 50, 60,000 range, so that you can comfortably consume the metrics and the events and process them through an AI infrastructure that is adept at being able to discover patterns and automatically pinpoint incidents that need action. And I would venture that there's going to be a shakeout as people realize when they're looking for a vendor in this space that the stuff that looks like it's shiny, claims to be SaaS, claims to be AIOps, turns out to be a first generation SaaS product using a rules-based system. It's kind of, in the tortured, fevered imagination of Netcall circa 2007, probably how they viewed the future. Well, the future doesn't look like that. The future looks like a tool that can cover the entirety of the observability data set and provide timely insights using advanced algorithms that are easy to use because they're advanced and delivered in a package that can scale.
So let's talk about like your key differentiators. So obviously scale is one of them, right? And you highlighted on that. What are some of other key differentiators? I mean, I know you guys, your situation room and things like that. There's a lot of really interesting things about your platform that you guys brought to the table around collaboration and things like that. So let's talk a little bit about that.
Yeah, well, collaboration is important. Although to us now, we see that much more as a blended picture. So it's not just about what you can do in our tool, but it's how you interact with, Slack, for example, and other IRC tools that perhaps are more last gen than a tool like Slack. But Microsoft Teams, and Zoom and so on and so forth all become important as well. And part of the reason for that is at the origin, as we started developing and conceiving of the algorithms that we use to do incident detection, we realized that what you would start to find is that the incidents would reflect reality and not reflect how people organize their problem remediation team. So in other words, typically an incident doesn't involve one discipline. You'll get alerts covering an application, infrastructure, database, compute. And what you don't want to then do is kind of work out which one of those disciplines you escalate to in a siloed fashion. So we conceived of the situation room as a way of bringing multiple different perspectives to view to fix a problem in very much the same way that in larger companies, major incident war rooms have been conducted, for time immemorial. So the idea is trying to elevate that sort of collaborative teaming approach to solving problems to basically be there for every problem. So that's a key differentiator. But honestly, I wouldn't go, if I was trying to convince somebody as to why Moogsoft is a better solution, I'd almost begin and end with a correlation, because unless you get that right, anything that you do downstream to the problem is highly suspect. And, you could end up just chewing up people's time sort of incorrectly. And, I continue to be amazed that, just some of the stuff that we consider almost to be table stakes in how we do incident detection really isn't. So I'll give you a very simple example. So how we typically generate an incident is we'll get alerts or anomalies or metrics coming in, and we'll start to conclude that there is a grouping of this data that corresponds to an impacting incident, and we'll raise an incident, start the process. But, things are not fixed in time. So, events change. So you might get an alert from a critical application that starts out as a minor alert and then becomes a major alert, and maybe the description changes, or, there are additional other metadata is attached to the alert. To the best of my knowledge, every single one of our competitors only considers the initial state of the alert, which means that everything that goes on after that is not taken into account as you decide what is the root cause and what is the shape of the incident that you're passing down the line. That's crazy. I mean, that is actually nuts that people think that that's a solution, because it really isn't. Because, the world isn't that simple. And so we find ourselves oftentimes when we're doing competitive bake-offs or, other demonstrations, people scratching their head and seeing that we actually capture things that the competitor products don't, or we capture them in a more sort of elegant and timely fashion. And, it's a very, very simple thing. The fact that, the timeline, when you look at a data set and you're trying to decide that there's an instant there, that is a decision that you're making that is contextualized in time. And depending upon the window of time that you use to make those decisions, you get a different answer. And so a lot of the innovation in our algorithms is having a flexible windowing of that time. All of the competitive products, fixed in time. So depending, if you get that sample rate right, great, you'll get the answer right. But it'll only be right for that particular instant, and it's likely wrong for all others. So having that flexibility in correlation time is vitally important. And I could go on and on and on in terms that probably descend into a kind of a slightly geeky arcana of correlation technology. But the general point that I'm trying to make is, there are hundreds of years of experience and investigation and pure research that have gone into building our ML and AI enabled solution. And as I look around the market, there's just a lot of people wrapping up regexes and, hard matching and rules-based systems and declaring it to be AIOps because they don't want to admit that they're legacy.
Gotcha. So one quick question regarding that. So when you think about grouping together, right? So you start seeing an initial outbound. What is some of the techniques that you guys are using for grouping things together? I mean, obviously, topology, connectivity, things like that. What are some of the things that people should know about that? Because it really is in the end the core, right? The correlation and core. You're right. Cool. If you're not correlating the problem correctly, and your point around the timeline and expanding or contracting that timeline appropriately, then anything you hand off to a team through any kind of notification or other downstream process is flawed. But kind of go a little bit even further, to the beginning of how these things get grouped together and what you guys think about from that.
So it boils down to a single word, which is similarity, and then you get into the various different things. So I pick up two random objects on my desk. There you are. A little thingy from the Geiger Museum in Switzerland and my mobile phone. How are they related? Well, you would start to ask questions about similarity, attributes of them, and then use algorithms to work out whether or not they belong together. And these attributes can be many, many, many different things. Now, I mean, to you and I, these look nothing, they're completely dissimilar. But if I pick up another object, which was a little statue of philosopher that was given to me by a team member in our Indian group, all of a sudden there's a lot more similarity between these two things than there is between, the Geiger alien and my mobile phone. And so it boils down to different techniques for extracting those attributes that you then compare for similarity, and mapping those techniques back to, if you like, the real world consequence of it. So you said a couple of them. So, topology, how close in an infrastructure or a dependency are, the sources of this alert and this time series metric? And are there ways in which I can, say that there's some overlap? Not exact match, that's kind of key, because when you're doing exact matching, you're doing rules. But is there some kind of overlap? The other aspect is time. Time's a very important part of how situations and incidents evolve. But time in a non-trivial way. So patterns of occurrence are do two alerts share the same pattern of occurrence and are occurring at the same time, may cause you to conclude that they are related in some way. I never cease to be amazed at how language, like you would never think that language in an alert, which is usually a pretty compact bit of text, can tell you so much about whether two given alerts are similar to each other, providing you are able to, in essence, fuzzy match the text. So you don't require, the two sentences to be, word perfect identical to each other, but you can pick up areas of overlap. We'll give you hints when to pull them together. And then, of course, there's the more supervised techniques to use a term that's more technical in machine learning, which is where you look to see how people have responded to an incident or an alert in the past and use those to correlate them together. Change. I think one of our competitors all of a sudden decided that there's nothing more to the world other than correlating change. Well, we've been doing this for years and years and years, and it's just a thing which we all understand, that if there is active change going on in an environment and stuff changes at the same time as you discover a set of alerts or metrics becoming anomalous or interesting, that you might want to point the application owner or the incident owner to that change incident. Although you may want to do something more sophisticated than just go and look up all change requests occurring plus or minus 30 minutes from the date of the start of the incident, particularly when you don't know when the start of the incident is. And so we do that again using similarity-based techniques of matching. So not everything about a change incident may overlap directly with the incident that you're considering. So in essence, it really all boils down to, you have what you know, you look at all of the metadata about what you know, all of the contextual information, and then you look for patterns of overlap and similarity and use that to deduce where your active incidents are.
Gotcha. So let's talk about a couple more things. I know that you guys have done this, your new next gen platform, and you've been in the SaaS world for a while, and now even more all in on SaaS. So talk about that as one of your key things going forward for customers.
Yeah, so we absolutely recognize that there is going to be a very evolved hybrid future for all of our customers, and what this typically means is people don't want to own the platform. They don't want to own the platform on which they are running their operations software, just like they don't want to own that platform on which they're running their accounting software. And so the pressure for us to be able to offer a really good SaaS experience for our customers has been there for a while. We decided a few years back that we were going to reimagine our platform and build a next-gen version of it that was SaaS first. And that's really what we've been up to. And we've used it as an opportunity to rethink through how we scale and how we offer our software to our customers. We want the experience to be much more self-serve, so that people can kind of get there as much as possible on their own. So that what we're doing is we're not spending time and chewing up their time teaching them how to do the trivial stuff, but really spending our time and for that matter your time helping them solve the thornier business problems around operations. And so we've sort of reimagined it from the ground up. It's a new platform rather than a new product. The capabilities that people were aware of in our last gen carry forward through into this new platform, and so a lot of the functionality will seem very familiar. It'll just be easier to live with, and we went from an upgrade process that was kind of much more sort of enterprising. And I like to tell people that today, because it's a day with a Y in it, there could be 5 to 10 updates to the entirety of our SaaS infrastructure, and nobody will notice because it's zero downtime, zero interruption, CI/CD built. And we also wanted to change how we engineered at Moogsoft as well, so we look like our customers. Our SRE team spends a lot of time in the community talking to other SREs. We use our own product to manage our own estate very actively. In fact, we call it champagne rather than drinking your own Kool-Aid internally, and it does a nice job for us. But all in all, it's been about trying to reduce the cost of ownership of AIOps for our customers. And we've had the advantage of being able to build a SaaS version 2 platform, which means that we are available, all over the globe. With we cover all of Amazon's availability zones pretty much, and fairly soon we'll be able to offer it as a multi-cloud environment as well. So it's very flexible, very easy for us to live with, and therefore very easy for our customers to live with.
Yeah, good. Well, I mean, it's it's been an interesting road with SaaS, right? I mean, if you would have thought back 10 years ago, I mean, there wasn't a single person in IT, especially in the infrastructure operations, that ever would have considered doing anything related to using a SaaS platform.
Yeah.
And I think ServiceNow kind of broke that ceiling, really kind of shattered it. And the benefits are just out there. I mean, my first software company was on-prem, and now we're running a SaaS platform, and it's an amazing thing from all sides, right? The customer experience is so much better. The engineering experience is better. The ability to roll out updates and fix things in the background that people don't even, as you said, people don't even know about. It's fantastic. And I think in your world, the ability to modify and load in new algorithms and just kind of release things out into the community is excellent. So last area we want to kind of talk about is metrics, right? You want to touch on that a little bit?
Yeah, sure. And it kind of goes back to a couple of comments I made earlier. One of the things that we always kind of did have in our mind as a thing that we wanted to do was to broaden the types of data that we consider in our analysis to include time series data. The classic sort of floating point delivered once every fixed period of time. So CPU load on a server measured every 30 seconds. That kind of stuff. And we really didn't have any kind of answer to that in the early days at Moogsoft. And the so what about it is, things fail in a different way now. You tend to get brownouts rather than blackouts. You tend to get stuff that will degrade over a period of time, then catastrophically fail. And what the metrics allow us to do is to reach back into the kind of the origin of a service impacting incident and provide just much more detail for somebody faced with a problem that they're trying to remediate, to allow them to diagnose and fix it faster. So it's kind of broadening the context for an incident. And it just simply is the case that typically things degrade before they fail. So if you can capture the degradation period, you may be able to avoid downtime. And that degradation period is entirely characterized by metrics rather than events.
So you bring up an interesting point, right? Because being able to capture metrics and look at degradation, that would also help you in dynamic thresholds and things like that, right?
Yes,
because as we all know, I mean, some applications normally would consume higher versus others, right? And that's not necessarily a bad thing. You just need to know what norm is and adjust accordingly. In the old days, we would we'd set rules, right? We would say, hey, if the utilization goes above 80%, kick off an alert. It's like, well, that application could be normally running at 85, 90% all the time, and that's normal, right? So do your metrics take that into account?
Absolutely. And, when we started thinking about doing metrics, the first question that we asked ourselves was, well, how would an AIOps platform do metrics? And certainly what it wouldn't do is it wouldn't set a rule, a manual threshold. Because, it's back to when is this data point an interesting data point? And it's interesting in the context of all of the other values it's ever had before. Everything has meaning relative to everything else, as opposed to as an isolated data point. So we built in dynamic thresholding. We built in the capability for us to improve our thresholding as we see more data. We do some stuff which is, it's kind of subtle but important. Like rather than, make assumptions around technicalities like the central limit theorem that, all numbers are randomly distributed in a normal distribution around the mean, which only really works in some very sort of limited, constrained features of the data that you're looking at. We do a much more model-based approach to understanding the distribution of a given data point and then trying to work out where an individual item is relative to that. So it's very flexible. Of course, there is still the capability if you want to put a hard limit on, I don't care what you think, tell me when it goes over 85%, that can be done. But we try and build into this model not just the point of telling you when you've got an anomalous value, but how anomalous it is in terms of the alert and event that we raise. And it's an area as well where there is very, very, very active innovation going on at Moogsoft. And I think through the course of the next year, some of the more dramatic improvements to the algorithmic capabilities of the platform are going to come as we roll out some recent work that we've been doing around the use of AI techniques like long-term, short-term memory, neural nets, recurrent neural nets, to the job of anomaly detection, which will be pointing at some cherry-picked data series rather than all of them, just because it's it's definitely a big sledgehammer. So you wouldn't want to crack every walnut with it. But there's a lot of innovation coming down the line with that. But already the platform is able to automatically deduce when a metric is anomalous, which is a huge advance.
Yeah. Good stuff. Well, I think we're coming up on our time. Anything else you want to cover? Any exciting things that you guys, any crazy announcement you want to make that we'll hear here first, or just anything to kind of wrap it up that you think your customers might want to hear about?
I love it. The craziness. Well, here's one thing that has been a real joy in the course of the last year. I mean, of course, Moogsoft has been grappling like every other business with enforced remoteness, although we've embraced it. I mean, we've decided that Moogsoft is going to be a remote first company going forward. But as part of the launch of the new product, and there is a self-serve capability in fact, please go to our website moogsoft.com and sign up for a trial if you're listening. But as part of that capability, just the reach with what we've been able to touch customers has so massively extended. We doubled our customer base in the course of the last 9 months, which I think is just nuts. I've not seen that in my career, where a relatively mature business like Moogsoft manages to pull off a doubling of its customer base. That's kind of crazy. And I think there are big tectonic forces at play at the moment in our industry, and expect big change. I feel like a 21-year-old guy all over again in this industry. It is so exciting, so fast-paced and so fast-moving, and has zero tolerance for people who want to sit back on their laurels and think they've got it all figured out.
Yeah, it's an exciting time. Like you and I are probably about the same age, and I just had a birthday yesterday, and I feel more excited now about what's going on than I have in a really long time. And it's just for people who are curious, about innovation and future. Now it's just a really great time, and so I appreciate you coming on board today. And as always, I will say I always enjoy talking to you because you're an incredibly smart guy that's able to make very complex concepts sound very easy. So, but I know that there's a tremendous amount of hard work and math and physics, and as an engineer, I was an electrical engineer that struggled through physics. I fully respect your background because I absolutely could not do it. But appreciate you coming on board, and we'll catch up soon. And good luck to you guys going forward, and we'll talk soon.
Sounds good. Right, great to chat, Sean, as always.
All right, take care. Bye, Phil.
Yeah, bye.
Thank you for joining us in this conversation about AIOps and the future of IT operations. Interested in a deeper dive on these topics? Check out our resources available at AIOpsevolution.com. And remember to subscribe to get the latest episode.